All right, exercise 6I looks complicated, but it isn't. You now have learnt most of the skills to actually go up to x to the power of 98. Okay, so here we go. X to the power of 4, notice, this is still the same as how I taught you. K is responsible for doing what again? Up and down, very good. We're mastering this now. So up and down, positive up, minus down. What about the x minus h? What does the h do again? Left and right. And the way I taught you is I said let it equal to 0. If you solve for x, if it's plus, it moves to the right. If it's minus, it moves to the left. Okay? And then finally, the a either tells you if it's kept the same shape, positive shape, or it's reflected. Yeah?
How would you find the left and right if you didn't do the x minus h?
I'll show you in chapter 7. So chapter 7 is the proper way. This one is my cheat way to get you guys.
This is easier.
Yeah. To do it quickly in your head. But there's a reason why it works. And A is either you flip up or down. Okay? So there's a reflection on the x-axis. That's right. That's right. So this also talks about how narrow or wide. Okay, so most times when you're sketching, people can't tell what the dilation is. So mainly it's the left, right, up, down. Now, I'm going to show you a couple of things. Let's do A again times x plus or minus h. I'll start off with squaring plus k. Right, so A, h, and k at the moment, this is all 1. So I'm going to change this to 0. So don't move left or right. Don't move up or down, so it stays at the center. Here's your quadratic. So that's your quadratic in black. What I want you to see here is, can you see what happens when I now change all to even numbers? So 2 is currently squared. Quartic is power 4. Okay, so the black line is the quadratic. That's power 4. I'm going to zoom in a bit. It's power 4. Tell me what you're starting to notice. I'm going to change it to 6, okay? So 4, let's change this to now 6, 8, 10, 12, 98. What are you noticing? Yes, so it gets more square, but it's actually more square between certain values. What two numbers does it get really square between? Minus 1, 2, 1. There is some mathematical reasoning to that if you think about it. Negative 1 to 1, that means it's a fraction. If you square a fraction, the denominator gets larger. The denominator makes it smaller. That's why, but you can work with that if you want. Okay, but at the moment, between negative 1 and 1, when it's fractional, every time you square it, it actually makes it smaller than what it would be. When it's a whole number, it skyrockets up. So it means that if you understand a square shape, which is what Anthony said before, it's symmetrical. Notice that every time the power, if the power is an even power, it will always be symmetrical. So even if I went up to 102, or I wrote, 102, it's still symmetrical. Whereas cubed, see, the reason why you learn squares, then you follow on with cubes, is it was asymmetrical, right? So that's cubed. But watch what happens when I now change it to 3, 5, 7, 9, and you'll start to see a pattern as well. So I'm going to change this to cube. Watch what happens. 3, 5, 7, 9, 13, 15, and then 99. What's happening again? It's asymmetrical, but it gets really square between, again, negative 1 to 1. That means if you understand the cubes, you understand the quadratics, you can technically sketch all of them. See, even if I kept it as 99, and I told you, what would the graph of y equals x minus 1 to the power of 99 plus 3 look like you can still guess this. You can say plus 3 means what? Up or down? Up. So up 3. What's the x minus 1 tell me? Right by 1. So I know, well, 1, it's 99, so it has to be asymmetrical. I know that the point of inflection, which is what you learned yesterday, point of inflection has to go to the right by 1, up by 3. So if I were to guess it, right by 1, up by 3, inflection point is here, but what I know is it should look really square. The only thing I don't know is where's the y-intercept and x-intercept. Get me? But the point is that I know it's moved across by 1 and goes up by 3. So let's test it. Watch what happens when I change h. We're going to move across by 1. So 1 and then up by 3. Here we go. You see that? Here's your inflection point, 1, 3. There it is. And that's what we predicted. 1 across, up by 3, that's my inflection point, and it's very square. I just don't know where the y-intercept and x-intercept are. It's probably a very, very small number. But the point is, that means you can do quartics the same way. Quartics is like quadratics. See, if I changed it instead of 99, go back to quartics, which is what X6I is. This is quartics, and it's the same thing. It's symmetrical like a quadratic, goes to the right by 1, up by 3, because I kept everything else the same. The only thing I changed was the power. And in your exercise, you're not going to do anything as crazy as the one I just did, where you go up to 99, because your exercise is this simple. This is all you have to do. They will give you something like this one. You look at the power, and you predict. This is a quartic graph. So if it's quartic, it should be symmetrical. So you know that it looks something like this, but it's a bit more square than a quadratic. What's plus 2 tell me? Up by 2. What's x minus 3 tell me? Right by 3. And looking at this, this is a positive 2, so it stays positive. If it was negative, it would have flipped upside down. But because it's positive, we know it stays this shape. If it was minus 2, then you know it would look like that. It will flip horizontally or vertically, right? So if I were to predict this graph right now, up by 2 to the right by 3, so right by 3, up by 2, here's my turning point. It's symmetrical, and the only thing I don't know is where's the y-intercept. So if I test that right now for you guys to see, change A to 2, change H to 3, change K to 2. There we go. We've got it right there, but I just don't know where the y-intercept was. So I assume the y-intercept was at 3, but it's not. But to find the y-intercept, how do you find y-intercept again? What do? Let x equal to 0. Let x equal to 0. So let's find y-intercept. So y equals to 2 times 0 minus 3 to the power of 4 plus 2. 2 times, now negative 3 to the power of 4 is like saying 3 times 3 times 3 times 3. What does that give you? 81, but it's not minus because if you do to the power of 4, it should all be positives. Yeah? So it's 81, but 81 times 2 is 162. And then you're plussing 2 as well. So, of course, my y-intercept couldn't have been at 3. It makes sense the y-intercept was at 164, which now if I go back, let's zoom out. Let's see where 164 would be. Let's see if it's true. 164 should be somewhere over here. And right. Whoops. Let's go out a bit. 164 is right there. There we go. So if I did, when x is 0, 164. There you got it. That's your y-intercept. So that's what I mean. That's all your graph is going to be doing. But when you're doing it, obviously just make it go all the way up, squarish, and back up. That's X6I. So what I taught you today is called power functions. That you can have it even powers or odd powers. Okay, so even powers versus odd powers. Even power is going to be symmetrical. Odd power is going to be asymmetrical. Now, in your exercise, they're not going to do x to the power of 7. They're not going to do x to the power of 99. But now you've got the idea. You can analyze it.
Does asymmetrical mean like it goes like this?
Yeah. So numbers are the same. It's just one's positive, one's negative. Yeah. All right. What about this one? How would you solve example 2? Looks scary, but it isn't. What do they all have in common? X, but not just X. X squared. See, this one has X squared. This one has an X squared as well because it's actually X squared times X. And this one is X squared times X squared. So that means they all have a factor of X squared. So if you factorize it, take out the X squared, and then you get X squared minus 9X plus 20. Suddenly, you're back to something you're more familiar with. Factorize this. That's quadratic. What do you get? X, 4 and 5, negative 4, negative 5. Now, if I asked you to solve for it, what are the x-intercepts? That's one of the answers. What would x equal to? 5. What would this one equal to? 4. And then don't forget, this one is also a bracket as well, even though we don't put it there. It means there's a turning point here. Yeah, remember what I taught you about when you square a factor? This is a quartic graph, and it has a turning point at where? X equals 0. So if I had to predict for you right now, if I predicted what the graph looks like, you guys can actually do it. This means it crosses through at x-intercept 5, crosses through x-intercept 4, but it has a turning point at x equals 0. Now a quartic graph is meant to have 4 possible intercepts. This one only has 3 brackets. So it means it's only going to have 3 x-intercepts. And it's a positive graph. So if it's a positive graph, it should look like a U shape. So how do you draw a U shape with 3 intercepts? There's only one way. Here's 0, here's 4, here's 5. If you have to cross through 4 and 5, but you can only touch 0, how do you draw a U shape? To do that, there's only one way, right here. I come down, here's a U, touches once, touches twice, or crosses once, crosses twice. See that? That is technically a U shape, but it depends on how many x-intercepts you get. Because there's only one way to draw a U kind of shape where you cross 3 times. Touches at 0, so it's a turning point at 0, crosses through 4, crosses through 5. So if I actually type it on your CAS right now for you to visualize, watch what happens. I'm going to delete all of these. You start to be able to predict this. So here we go. Y equals x squared times x minus 4, 5x minus 4. And let's go home. Look at that. Exactly what we said. Turning point at 0, cross through 4, cross through 5. That's another level. At year 12 level, I teach a bit more on top of that. But you should be able to start to look at factors now. Just look in the brackets. It tells you the number of intercepts. You look at the power to tell you, is it asymmetrical or is it symmetrical? Let's test your understanding. What do you think this graph would look like? So I'm going to give you a bit of a number now. So I'm going to do x minus 1, x minus 2, x minus 3, x minus 4. What's that? How many numbers is that? That's Q5. Yeah. Can you predict that? Have a go with this one. I know it's not part of your course, but if you understand what I'm teaching you, you should be able to predict what that graph looks like. Start off with the number of brackets. How many brackets do I have there? So how many intercepts do you expect? There should be 4. What kind of power function is this? Is this a odd power function or even power function? Expand the brackets. Expand all of them. So think about it. So x times x is x squared, times another x is now x cubed, but then when you times this one, this is an x squared. So what do you get overall? Think about it. This first 3 was x cubed. If you take an x cubed and you times an x squared, what do you get? X to the power 5. Is that an odd or an even function? It's an odd. So it should be asymmetrical. So if you were to think about it, what's an x to the power 5 look like? It should look asymmetrical, a bit squarish in the center. Now, how do you draw this shape where you cross 4 times, but it has a turning point at 4? X equals 1, x equals 2, x equals 3, x equals 4. Can you draw that shape? 1, 2, 3, 4, but it has to have a turning point at 4. It has to have this shape, crosses through 1, 2, 3, but sits on 4. What would that look like? There's only one way to do it. I can't see it. That's all right. Let's do it on Desmos. So have a think, even if you're just picturing it. Remember, this is a positive graph. So if it's positive, it should look more like this N shape. If it was negative, the other way down. So let's watch. Y equals, I did x minus 1, x minus 2, x minus 3, and then x minus 4, but I did to the power of 2. Hands up if you got something like this. So it looks like your N shape. Crosses through 1, crosses 2, 3, but sits on 4 and continues on. Hands up if you got this idea. Okay, not bad. That was me pushing you. And you're not getting tested on that. But that would be an investigative idea where I would test you and say, what happens if I put another bracket? What happens if I put an A or a B? That's what you're doing. Okay, and then you can apply everything I taught you. Plus 1 gives it up, shifts it up and down, that kind of thing. All right, team. I think I'm going to stop there. It's a bit long of a session today. Actually, we've only got 5 minutes left, but I hope you learnt something new today. Something explorative. I'm pretty sure all the other Year 11s do not know what I just taught you there. You can teach them something. If you can teach them, it means you get it. If you can't teach it, you haven't really fully got it. Okay, so you got even powers versus odd powers. All right, I'm going to stop the video.